let us go to stainless steel. As I was telling, stainless steel has so much of chromium and sometimes nickel that normal iron carbon diagram cannot explain how the solidification will take place. So, what is important is to draw another diagram which will indicate what are the different delta and gamma for different chemistry of stainless steel. So, now I have shown here different stainless steels, 430 it is a ferritic grade, hardly any nickel, mostly chromium grade. 301 is, as you are going this side means, look what is happening, nickel equivalent by chromium equivalent is this horizontal axis. In iron carbon diagram it was carbon or carbon equivalent, here it is nickel equivalent by chromium equivalent. That means from this diagram all stainless steels can be represented in this diagram. How? By calculating what is the nickel equivalent by chromium equivalent. I will show in this figure how nickel equivalent, chromium equivalent are found out. Chromium equivalent means chromium is basically ferrite stabilizer. So, whatever alloying elements which stabilize ferrite, they will go to chromium equivalent, calculate. See, chromium, actual chromium plus the different factors are there, 1.37 moly, 1.5 silicon, 2 niobium, 3 titanium. So, these are all stabilizing ferrite and stabilizing chromium. So, increasing chromium equivalent. But look at the other elements, manganese, carbon, nitrogen, along with nickel of course, copper, these are all austenite stabilizers. So, they increase the nickel equivalent. So, this since chromium and nickel are the two important alloying elements for stainless steel, what has been done is all the alloying elements have been divided into two broad categories. Whether there are ferrite stabilizers, then they are put together for finding out the chromium equivalent. If they are austenite stabilizers, then they have been put together along with nickel, because nickel is the austenite stabilizer and chromium is the ferrite stabilizer. So, how solidification will take place through ferrite, that means delta, or through austenite. So, in iron carbon diagram it was everything by carbon or equivalent, carbon equivalent. Here we have to look into the two alloying elements, chromium and nickel, and not just chromium nickel, the chromium equivalent or nickel equivalent, because chromium stabilizes ferrite, nickel stabilizes austenite. So, how the alloying elements are stabilizing ferrite or austenite, if you understand that, so we have determined what is chromium equivalent, what is nickel equivalent. So, for any stainless steel we can calculate what is chromium equivalent, what is nickel equivalent, and we can calculate what is the ratio of nickel equivalent by chromium equivalent. That is what we have shown in this figure. So, this nickel equivalent by chromium equivalent we have plotted along this horizontal axis. This is the temperature. So, all the popular grades I have put, 430 is a ferritic grade, stainless steel grade, 301 almost austenitic grades, 304 we are increasing austenite, 310S totally austenitic grades. So, now like iron carbon diagram, what was happening, less than 0.1% carbon it was totally ferritic. So, here what is happening, less than this is 0.5, so this is 0.55, less than 0.55 nickel equivalent by chromium equivalent, only delta. So, you have initially liquid, then liquid plus delta, then delta. So, solidification is complete only through delta for nickel equivalent by chromium equivalent less than 0.55. If you have nickel equivalent by chromium equivalent more than 0.55, look at this particular grade of stainless steel 310S is very much austenity, only austenitic solidification is taking place, liquid, then it is going to liquid plus gamma, then finally gamma. So, like percentage carbon indicating what is the mode of solidification, here nickel equivalent by chromium equivalent is indicating what is the mode of solidification, what is the solidification sequence. For lower nickel equivalent by chromium equivalent only through delta solidification is taking place. Only after delta is formed, that means solidification is complete, then only gamma is coming here. In between 0.55 to point, this is 0.55 and this is say this is 0.7, so 0.75. So, in 0.74 actually is this value. So, this range indicates delta plus gamma and beyond this gamma. So, like iron carbon, this portion is only delta solidification, this portion is, that means high nickel equivalent, chromium equivalent very high, only gamma, in between delta plus gamma. Look at 304, what is happening? Initially liquid, then liquid plus delta, then delta plus delta to gamma, this is the delta gamma, liquid delta gamma phase field. So, this delta to gamma is taking place almost near solidification complete. So, as I had mentioned you, when this delta to gamma solidification is taking place is very important. Look at 301, solidification is complete through delta and delta to gamma is taking place after solidification. 304, delta to gamma is taking place just before solidification. 316, delta to gamma is taking place much above completion of solidification, just say around say 0.3% of solid fraction. That means during solidification and towards the almost towards the beginning of solidification 316. 310s, no delta at all, solidification only through gamma. So, these are all very important information for understanding what is the sequence of solidification. Is it the solidification taking place only through delta, only through gamma, or delta plus gamma? If it is between delta plus gamma, then when delta to gamma is taking place during solidification? Like 304, you see delta to gamma is starting here and solidification is complete here. So, before solidification or towards the end of solidification, delta to gamma is taking place. 301, solidification is complete, no gamma formation has started, only just below the solidification we have delta to gamma transformation, solid state transformation. 430, totally ferritic grade, liquid to delta, only delta, solidification is complete here, gamma is taking place quite below the solidification, solidification is complete here. So, gamma is taking place only at around say 1200 degree centigrade, solidification is complete at say more than 1400 degree centigrade. So, 301, solidification is complete at around say 1400 and then gamma is taking place just beyond, maybe 20 degree below this, is just delta to gamma is taking place. So, even if delta to gamma is taking place in during the solid state, where it is taking place is important. Whether it is within solidification range, then at what stage of solidification, like 304, delta to gamma taking place towards the end of solidification. 316, I mean at much higher region of solidification. So, solid fraction will be say around say 0.3 here, here solid fraction is maybe 0.75 or 0.8 here or maybe 0.8, 0.85. So, delta to gamma transformation, where does it take place is very important. Why again and again I am repeating? Because delta to gamma generates lot of strain. So, that strain is going to create some problem during solidification. So, that is why where it is taking place is important. At what stage of solidification is taking place or whether it is taking place in solid state, these are all important. So, as I was telling in stainless steel, unlike iron carbon or plain carbon steel or low alloy steels, carbon equivalent, their carbon equivalent can determine the mode of solidification. Here the ratio of nickel equivalent by chromium equivalent determines the mode of solidification. So, we are finding out chromium equivalent depending on what are the aluminum elements present, we are finding out nickel equivalent, what are the aluminum elements present. 430 grade, that was having quite small amount of nickel. So, the nickel equivalent or chromium equivalent was quite low. So, if it is quite low, then what is going to happen? Ferrite potential will be very much positive. So, it is delta solidifying. Look at this figure. Here 0.74 is this particular chemistry. So, beyond 0.74 it is only gamma solidification. Yeah, if you have a nickel equivalent or chromium equivalent of say 0.75, let us say, then what is happening? 0.74 minus 0.75, that is minus into 5.26, thus the whole thing is negative. So, ferrite potential is less than 0, that means it is gamma mode. So, if nickel equivalent chromium equivalent is say, if we look at this figure, say less than this figure 0.55, then what happens? If you multiply 5.26 into 0.74, okay, this figure, this is basically, this is the figure, yeah. So, that means when you are going to a particular nickel equivalent chromium equivalent which is less than this figure 0.55, so then your solidifying is totally delta. So, this equation indicates, suppose we have a say 0.74 minus 0.55, how much it becomes? 0.19, then you multiply it with 5.26, it becomes 1. That is why the significance of 0.74 is that, because 0.55, if you deduct 0.55, yeah, the nickel equivalent of chromium equivalent is basically the ratio, if you deduct with this and then multiply with this, so basically it will give 1. So, that means delta solidifying is more than 1. So, please try to remember from this figure what I have told is, whenever nickel equivalent by chromium equivalent ratio is more than 0.55, you have delta solidification. If it is more than 0.74, it has only gamma solidification. When this ratio is in between 0.55 to 0.74, it is delta plus gamma. But this relative, when delta to gamma will take place, will depends on this. As you are increasing nickel equivalent and chromium equivalent, delta to gamma is taking place at earlier temperature, during solidification. This is what is important. So, I have tried to explain the role of chemistry, that means basically what is the solidification temperature range, how the solidification sequence will change with chemistry, what are the type of solids delta and gamma during solidification, and even beyond solidification, lower temperature than solidification also these relative proportions may change. The chemistry will dictate how the solidification is taking place and what are the relative proportions during and at temperatures lower than solidification. So, there are 3 possible routes: liquid going to liquid plus delta, then delta and then gamma. So, this is the situation for carbon less than 0.1, then another may be liquid going to liquid plus delta, then liquid plus delta plus gamma, then gamma. This is the situation for a carbon content between 0.1 to 0.5. Another sequence may be liquid going to liquid plus austenite and then austenite only. You look, finally everything is austenite when you are coming to low temperature, maybe around 1000 or 1100, but how it is coming, what are the sequence, that is changing depending on your chemistry. For, as I have told, for iron carbon it is the carbon or carbon equivalent, for liquids stainless steel it is the ratio of nickel equivalent by chromium equivalent. So, that factor, that means the chemistry will dictate carbon equivalent for plain carbon and low alloy steels, and for stainless steel nickel equivalent by chromium equivalent, this ratio will determine the specific chemistry, and will dictate how the solidification takes place. So, again I am repeating, it is important to understand when delta transforms to gamma, as I was telling you, looking at the different figures. If it occurs during solidification, then at what stage of solidification, as I was giving examples of solid fraction, at what solid fraction during the early stage of solidification, later part, or still lower temperature, then after solidification is complete, when does it take place? And I have mentioned why all these are important, because delta and gamma strength of solid shell is different. So, whatever solid shell is forming, it has a different strength depending on whether we have delta or gamma. Also, I will come to it later on, it will also indicate the segregation is also not equal for delta and gamma. All of us know the segregation will take place between solid and liquid, but what is the solid? That will dictate what is the extent of solidification. What is the solute? That will dictate what is the extent of solidification, or what is the extent of segregation. So delta and gamma sequence of solidification, whether it is delta, delta plus gamma, or gamma, whether it is delta ferrite or austenite or a mixed mode, is important from many factors. First, the strength of the solid shell, because it is different from delta to gamma. Second, segregation, it is also different, extent of segregation is different if solidification is through delta or solidification is through gamma. And also this delta to gamma, when it takes place, this is important because it generates some stress, some strain, some contraction, because it contracts in volume. So, that strain will be incorporated. So, at what stage is getting incorporated is important, whether the shell can withstand that strain or not. So, whether during solidification or after solidification, these are all important issues. So, you see, delta to gamma is taking place where if it is during solidification, that means between this 0.1 to 0.5% carbon, at what stage delta to gamma is taking place, that is important. If it takes place here, that means it is delta to gamma is taking place near the eutectic peritectic temperature, but if it is for this carbon, say 0.2, 0.3, then it is taking place lower than at the lower end of the solidification, but that is important, is what stage is taking place. And here it is taking place, delta to gamma is taking place when the solidification is complete, towards the end of the reaction, solidification reaction is taking place. So, these are important issues. So, then I have told for stainless steel, iron carbon diagram cannot indicate the sequence of solidification. So, we must have a different diagram where instead of carbon equivalent, we have this ratio nickel equivalent by chromium equivalent. More the austenitic solidification means we are going to higher nickel equivalent by chromium equivalent. At this ratio of say 0.55, less than that, it is totally delta solidification, only delta ferrite. Beyond 0.74, it is only austenitic solidification. In between 0.55 and 0.74, we have mixed, and for different grades depending on this ratio, at what location this solidification takes place also is dictated. So, for stainless steel, we find out chromium equivalent by nickel equivalent depending on the chemistry, specific chemistry, and from this equation we know what is the ferrite potential. That indicates if ferrite potential is more than 1, then it is totally delta solidification. That means ferrite potential is less than 0.55, 0.74 minus 0.55 into 5.26 is basically this figure 1 you will get. So, it is more than 1. If it is less than 0.55. So, if it is greater than 1 ferrite potential, delta solidification, and if the ferrite potential is rather if the nickel equivalent by chromium equivalent is more than 0.74, that means this is negative, this ferrite potential. If it is negative, not negative, it is a fraction, it is less than 0, that means it is a delta mode of solidification. So, less than 0 is negative, so it is a delta mode of solidification. So, more than 1 delta, between 0 and 1 delta plus gamma, less than 0, that means it is negative, it is gamma mode of solidification. That means it is becoming, as the ratio between nickel equivalent chromium equivalent is increasing, we are coming to more and more austenitic solidification. That is the whole idea. Thank you very much.